So hello and welcome to my shop. My name is George and I'm coming to you from Chelsea, Quebec. Now, one of my subscribers, William Fox, suggested that I make something for the shop using my 3D printer, and he suggested something along the lines of a micro adjuster, and I'm still trying to wrap my head around that, like how would I do that. But in the interim, I was thinking about it, and I've made a lot of objects for the shop using my 3D printer. So I thought I would dedicate one video to just showing you the tools and gadgets that I've made specifically for the workshop. And there may be a couple of other things that might be interesting, even if they're not specifically for the workshop. So, dust collector is place number one to take a look. There's 5 different items here that I 3D printed for the dust collector. Now I've recently rejigged the dust collector to have a second stage, or technically I should call it a first stage because things come into the cyclone first. And as you can see, it's been rejigged. The impeller is here up top. There's the motor. Cyclone down here, and a garbage can lower still. And in coupling all these things together, there's 3 different items that I 3D printed specifically for this arrangement. So there's a flange in black up here connected to the impeller and coming down. Comes down to a couple. Here it was printed in yellow, just happenstance. A couple that goes to the cyclone, so that's number 2. And here on the input side of things, I'm not sure if you can see it, but there's a reducer that goes 5 inches at the cyclone end to 4 inches for the piping that comes off of it. Now, to show you the 4th thing, I'm going to have to change the camera position, so hang on. Okay, so now we're looking at from a lower stance. So here's the bottom of the cyclone, and here's the top of the garbage can down here. Now, you need a seal between the garbage can and the cyclone. So I did that with a couple of sheets of plywood and a gasket in between. But to hold the garbage can up tight against the plywood, I made these clips out of plastic. So again, 3D printed, there's a dozen of them. To amuse myself, I made them in 3 different colors, but there you have it. So that's item number 4 for the dust collector. And the last item, again, I'll change the camera position. And so then I looked at this box full of all these different bits that you acquire over the years, and I said, oh, why don't I just 3D print a handle? And so I 3D printed this short, fat one that is really well suited for getting into this corner. So there's a hexagonal hole over here, 1/4 inch, just perfect for all of these bits. And this just sits there on the dust collector. So that's the 5th thing just for the dust collector. Okay, here's a fun little sideline. I made dovetails, 3D printed dovetails. So I started by defining the tails, and I defined the tails as a separate unit that I then fused with the panel. Then I took the tails as a separate unit and I turned them 90 degrees, and I took that unit and subtracted it from the end of the pin board, and that gave me the pins, right? Because if you take away the material that's the tails, you end up with the pins. And this is a perfect example of old brain handling new technology. Because my 3D printer took one look at this and said, what do you need dovetails for? I can print the whole flaming box. And yeah, that's what I did. I started printing boxes all in one shot. Some of the supplies for the shop I keep in special 3D printed boxes. So these have brads, pins and small batteries like watch batteries. The beauty of the 3D printer is that you can precisely tailor the box to suit the item that you're holding on to. So here's one with an inset lid, and it contains some of the longer pins for my 23 gauge pin nailer. I have brads in this one, different style of lid. This one, of course, for my 18 gauge nailer, staples, and then some 2 different sizes of brads. Small watch batteries in tiny little cases. And here's yet another one containing pins. This one with 2 sizes of pins. But check out the enclosure. I've made a lid that's specially tailored to the sizes of the brads that each side holds. So you can have some fun with your 3D printer as well. Now, do things always work out? No. Sometimes you'll blow the lid, you'll make a lid that doesn't fit because you didn't think things through correctly. And when that happens, you might have a tray where you can put parts that you just don't know what to do with at the moment. I've printed a variety of battery cases, sometimes for an item in the shop, like light emitting diode illumination, and sometimes for an object that I'm building. So here in the background, for instance, are the components that are going to go into a piano light. And here's the battery pack for it, the gray thing in plastic. And so different variations in front of you. Here's a battery pack that I put in place here as part of a broken charger. So the contacts fell off the charger, and so I took out its guts and I added my own battery holder, and this is working well. So here are 3 batteries in series that will run the piano light, and then a few other cases. Some of these are designs along the way to a final design that I'm really happy with. Here's a tiny little one. This is one of those 12 volt tiny batteries connected to a little device that sends a radio frequency signal back to the house, and I'm hoping to attach it to my dog and know when she's out of range. Now, I really like the way I've arranged the contacts. I have trapped in these little recesses here some hex nuts. They're made in they're in brass, and soldered to them is the wire lead. So these guys go in here, and when the screw tightens itself against the battery terminal, you get really good contact between the battery and the wiring. The special advantage that you get from that is that contact also becomes the switch, because as soon as you pull the screw away from the battery, you break contact, and so there's your on-off switch all built in to one unit. I pulled a little fan out of a computer. I think it was either a power supply or some other part of the computer. Anyhow, it's a little fan that was attached to the computer, and so when I pulled it out, both sides were open. So what I wanted to do was encase one side. So I made a 3D printed enclosure for it. So air intake comes in through here, and it shoots out of the tube. And so I park this close to where I'm using a coping saw, and it blows the dust away as I make the cut. I attach a 9-volt battery to this end to operate it. And here's a flip stop for the table saw. Here it is in the open position, and there it is in the closed position. So, no, not the mustard bottle, but the funnel for the glue bottle. So I like to keep it topped up. It was Matthias Wandel who shared that tip with us, that if you keep your dispenser topped up, you don't have to wait forever for the glue to come out. So I have a 4-liter container of glue that I use to top up the bottle, and this 3D printed funnel is wide at the bottom, but not too tall, and so it's got just the perfect dimensions for funneling the glue into the bottle. Again, if you have a 3D printer, you can make tools that precisely suit your needs. Now, half the fun, no, 90% of the fun with the 3D printing is designing what you're going to have your printer do. So I thought I would make this thing. So it's a coin bank, it's a coin sorter, and it's a coin counter as well. All three things. So it's a coin sorter because it just drops the coins into the right slot as they go rolling down. These are Canadian coins. Maybe you've recognized them. So there they go. And of course it's a coin bank because the coins are now sitting dimes with dimes, nickels with nickels, and so forth. It's also a coin counter because I created the heights of these cylinders to hold exactly the right number of coins. So here the loons, as soon as you can slide one off the top, the ones that are left behind amount to 25 of them, and that's how many you would need to roll if you're taking them to the bank. So yeah, like I said, not really a shop tool, but it was great fun making it, and the thing does live in the shop because that's where I empty the change. And then there are tool holders. So I have a French cleat panel behind me, and so I started making some 3D printed tool holders for French cleats. So here's one with rectangular openings that run through, and you can see they've got some calipers and a pair of scissors that I use to hang on the tool board. And so there's the triangle back here that sits on the French cleats. Here's another one, and what's special about these is that with the 3D printer you can very easily make a conically shaped interior to hold the chisel just so. So here's a couple of, oh by the way, highly recommended, the Sweetheart series, available through Lee Valley. They're wonderful. So while I was making tool holders, I thought, hey, I could make a general purpose tool holder that's not committed to anything. So I made these guys, and what you can do with these is shape a proper tool holder for the tool itself, either 3D printed or maybe make it out of wood, either way. And then you can just drive a screw through the back here into the wooden tool holder part, and so there's your tool holder. But there's another hole down here, and if you have a spot someplace where you'd like to hang a tool but there's no French cleat system, well, you can just turn this thing upside down, drive a screw into the stud up here, and then use another one of these as the actual tool holder. So at once, this is the wall-mounted French cleat and the tool holder, all made out of the same thing. So here's a Moxon Vise work-alike that I've got permanently attached to my bench. And when it's time to cinch things up, I could go get a 3/4 inch wrench to tighten up the 1/2 inch bolts. But instead what I did was I printed these little wings, if you will, that sit on the bolt heads, and have them sitting here permanently to cinch things up. So here's a partial success that I'd like to tell you about. So these are the little plastic wrenches that I'm using on my half-inch bolts. This is an earlier design. The later design works even better. So here's a flat one that you can turn by hand. But here's something that's really special about 3D printing. What I wanted to do was make a rotating handle on the wrench. And this is it over here. So this sleeve is free to turn. So there's a rod that goes all the way through and a cap over here that keeps the sleeve from coming out. But the special thing about 3D printing is that this thing was printed all in one shot. So you allow a little bit of a gap as you're printing this thing, and then there's some very thin plastic pieces that keep the thing together as it's being printed. When it comes off the plate, you just crank it apart, give it a few turns, and that smooths out any roughness. So there it is, you know, a crank that turns freely, but the special thing is it's all printed in one shot. I made a variety of marking gauges. So here, for example, I have a right hand and a left hand tri-square of sorts. Since the 3D printing gets done on a flat plate, it would have been awkward to have a properly thick end for a proper tri-square. So I printed it in two parts, one left hand and one right hand, so that this face was flat against the plate. I am going to try to print a proper tri-square someday, but these have been working quite well. The thing I like about the plastic is that it's lightweight, very easy to manipulate, and when you're working on small parts, these things become very easy to hold against the work. And their accuracy, I find, is good enough. I'm sure others will find the accuracy appalling, but for woodworking, I find these are good enough. So a couple of tri-squares and some attempts at dovetail markers. Now I have made a dovetail box using these markers, and they seem to work well. So a right angle on one side, and then a 1 in 8 angle on the other two edges. And you can flip it around as you come close to the edge of the board. You can flip it around and use the opposite edge, so that you've got a big registration area when you make your when you make your lines. So here's one version. Here's one that has angles on both sides. And here's one that can act as a saddle square of sorts, or just a regular square. Lots of different variations. This guy I used again as a square, and with the holes running along here, you're able to run a line parallel to the edge at different positions. And I made this one specifically for an LED lamp that I was working on, where I wanted the intervals to be 1 inch apart for one row of light emitting diodes, but the next row should be staggered by 1/2 inch. So this slit here is 1/2 inch away from the two edges, and I was able to register the rows using this thing. It worked really well, and again, it worked really well because I was working on a small workpiece, so this was very easy to hold against it. Here's another variation. This one is also a square of sorts, but instead of having a flat, fat edge, it has two bumps. And this one works well when you want to make radial lines on a curved surface. So the two bumps hold this edge at 90 degrees, if you will, to the edge. So even if the edge is curved, this will still be pointing towards the center if the curve happens to be part of a perfect circle. So all kinds of special little contraptions that you can make with a 3D printer. So there we have it. That's pretty well it for the collection of 3D tools that I printed for the Woodshop. I've had the 3D printer for not quite a year yet, and I'm still enjoying it. I hope this has maybe answered a question or two that you had on your mind about what a 3D printer can be good for to a woodworker. So thank you for sticking it through to this point. By all means, make some time for your passion and share it.